Hello everyone, this is a beautiful question of the collision. Let us go through the question first. Elastic collision is taking place between two particles A and B which have the same mass. We know one thing, whenever the mass is same and there is elastic collision, the particle exchanges their velocity along the line of impact. Okay, now they were moving in the same direction. A is moving at a speed VA and particle B is moving at a speed VB. In the given diagrams, the solid line represents the motion before the collision. See, solid lines means we can see the segments of the graph, such as if we see here, this is a solid line, this is a solid line. Then here are the dotted lines. Similarly, if we look at few graphs here, this is a solid line, this is a solid line, then here are the dotted lines. These are the dotted lines. This is a dotted line, this is a dotted line. I hope you got it. Now, this was a dotted line, this was a dotted line, and then here were the solid lines. This is a solid line, this is a solid line. Okay, I hope you got the graphs. So, the dotted lines are representing the motion after the collision and the solid lines are representing the motion before the collision. And where A has been written, that is for particle A, and where nothing has been written, obviously that line is representing the motion of particle B. So let us start the computation. If we look at all the xt graphs, here, here, here and here, they are basically same. All position versus time graphs are same. It means to choose the correct option, you have to carefully check the velocity versus time graph. So let us start the computation. At this moment of time, the x means the position of A and B becomes same. It means they are colliding at this moment of time. And if we check the slope of the xt graph, the A has more slope as compared to B. See, that blue line is basically for B. This blue line was for B. Okay, check the slope for A, check the slope for B. A has more slope. So how the picture should be? Actually, if you draw the diagram just before the collision, this is particle A of mass m moving with the speed VA. This is particle B having mass m moving with the speed VB. We are making this picture just before collision. For collision to take place between them, VA should be greater than VB. Obviously that should happen. If VA is greater, then it will go and hit the particle B. The collision will take place. Suppose the B and A, these are two particles. B is moving at a speed of 10 meter per second and A is moving at a speed of 50 meter per second. Obviously, A will go and collide with B. On the other hand, suppose if the A is moving at a rate of 5 meter per second and B is moving at a rate of 10 meter per second, their gap will keep on increasing. B will run away, A will never hit B. So if collision is taking place, then we can see one thing, that VA must be greater than VB. And if we look all the xt graphs, the slope of xt graph gives the velocity. So this VA is more, it has more slope. Comparatively, VB is less. Similarly, we can see in all the graphs, A has more slope. Okay. Now making the diagram after the collision. This is particle B. This is particle A. They exchange their velocities. It means this particle will now have the speed as VA and this particle will now have the speed VB. This picture has been made just after the collision. So there is simple intuition. Before the collision, who is moving faster? Before the collision, A is moving faster. And after the collision, who is moving faster? B is moving faster, because we earlier established that this speed VA was greater. So after the collision, the velocity has been exchanged and B is moving faster. Let us see which velocity versus time graph has this information. Suppose I check this graph. Here, if we observe carefully, before the collision, the speed of A is, let's say, shown here as V, and dotted line shows the motion after collision. This is the dotted part, and the speed of A is shown at the same level. Means this graph is telling that speed of A before the collision, the solid part, and the speed of A after the collision, the dotted part, they are same. Will it happen? No. Due to collision, the particles have exchanged their velocities. How the speed of A can remain same? It means this option is wrong. Now look at this graph. They are telling the speed of A is higher as compared to the speed of B, where nothing is mentioned, that is for particle B. Now solid graph is before the collision. So before the collision, the VA is higher. Yes, before the collision, the VA is higher. After the collision, the speed of A according to this graph remains same, which is not the case. So we can delete this option. Now look at this option. Here is VA. Obviously, then this should be VB. We established that solid part represents the motion before the collision. So before the collision, the VA was greater, but the graph is showing the VA to be less. It means this is wrong. Now look at this graph. Here is VA. The solid part represents the motion before the collision. Here is VB. This solid part represents the motion before the collision. So before the collision, VA should be more, VB should be less. Yes, that is absolutely correct. VA should be greater, then only the collision will take place. And after the collision, they exchange their velocities. It means if you look at the dotted part here, see this is a dotted part of the graph. Similarly, this is a dotted part of the graph. After the collision, the particle A has how much speed? After the collision, the particle A has the speed equal to VB. See, the dotted part of the graph, which is now showing for A, has the speed VB. Okay. And after collision, the particle B has the speed V. After the collision, the graph is shown dotted. And here the dotted graph has mentioned no letter. It means that is for B. And now the particle B has got the speed VA. It means this is the correct choice. I hope you got it. Stay awesome. Fire up the chat box if you have any doubt. See you in the next video.